Now, in this problem, the problem statement is a body is allowed to fall freely from a height of 30 meters. So, suppose this is a height of 30 meter and a body is allowed to fall freely from this height 30 meter. It says that where will its kinetic energy be twice the potential energy? Okay. Suppose we take a point x. Suppose this is the point x. At which point, this point we measure from the ground. This is the ground part. So this is the height x. We say that this p point, at this p point, the kinetic energy be twice the potential energy. Okay. So now I have to find out the kinetic energy at point P. So at point P, the kinetic energy is equals to the half of m v square. And suppose the mass of this object is m. Mass of this object is m. Okay. We take this. So we now have to find out v square. We know a formula which is v square equals to v naught square plus 2as. Okay. Here our v naught is 0 because I allowed it to fall freely, so our v naught is 0. Okay. And the bodies fall due to the gravitational force, so we use gravitational acceleration g instead of a. And how much distance it travel? This travel, and this as this distance is x meter, and the height of the building, or the height of the tower is 30 meter. So this point will be 30 minus x. This point, what will be? This point is 30 minus x. So you can write 30 minus x. So I replace this v square with this 2g into 30 minus x. So then I will get mg into 30 minus x. Okay. So this is our kinetic energy at point P. Now I have to find out the potential energy at point P. So the potential energy will be mg x. Okay, we know the potential energy for a gravitational force is mgh. Here our h is the distance from ground to that point. So here the distance from ground to P point is x meter. We suppose this thing as x. So this is our mgx. According to our question, so we can write according to question. So according to question, our kinetic energy be twice the potential energy. So if our potential energy is Pe and our kinetic energy is Ke, so our kinetic energy will be twice as potential energy. So to be equal both sides, we will add 2 at the left hand side, because the kinetic energy is greater as twice. So to equal this whole thing, we add 2 in the with potential energy. Then we can write, as we know the potential energy is mgx, we can write 2 mgx. And for kinetic energy we can write mg 30 minus x. Mg 30 minus x. Okay. Then if I calculate the whole thing, then I will get x equals to 20 meter. X equals to 20 meter. Okay. So this is the answer of our of this question. Okay. So at 20 meter, the kinetic energy be twice the potential energy. I hope you understand this question solution. Okay. Now coming to the next one. The next question is, a block of mass 4 kg while moving a velocity of 2 meter per second strikes a spring. Comes to rest after compressing it through a certain length of the force constant. If the force constant of the spring be 30 Newton per meter, calculate the length by which the spring is compressed. So what is this thing? This means that a block of mass 4 kg. So this is a block of mass 4 kg. Okay, moving with a velocity of 2 meter per second. This is the velocity. This is m equals to 4 kg and this is velocity 2 meter per second. Strike a spring. Suppose this is our spring. This is our spring. Okay. When it strikes this spring, then the scenario is, suppose, so this is the scenario. That means this spring is compressing a certain length. Suppose this length is x meter. So it is compressed with x meter due to this block strikes this spring. So what happened in this scenario? As this box is moving, it has a kinetic energy. It has a kinetic energy, and as the spring is changed its position, so it conserve a potential energy. It conserve a potential energy, and here our kinetic energy is changed to potential energy to compress this spring. So we will use this concept to solve this problem. Now coming to the solution. Okay, so first of all we have to find out the kinetic energy of that box. So kinetic energy of that box will be half of m v square. This is the formula, and we know the value of m is 4 kg and the velocity is 2 meter per second. So the kinetic energy will be 8 joule. Kinetic energy will be 8 joule. Okay, and we know for potential energy, for spring, the potential energy is equals to half of kx square. And here our k is used to our spring constant, and here our question given us that the spring constant k is spring constant k equals to 30 Newton per meter. Now, as I mentioned earlier, that here our kinetic energy is converted into potential energy. So in that case, our kinetic energy will be equals to the potential energy. Kinetic energy will be equals to the potential energy. Here our potential kinetic energy is 8 joule, and for potential energy we will use the formula half of k x square. From that we will get kx square equals to 16. Okay, or you can write x square equals to 16 by what should I say? The value of k is 30. Or you can write x equals to root over of 16 by 30. 16 by 30. If I calculate this whole thing, I will get the value 0.73 meter. So it compressed the spring of 0.73 meter. So this is the solution of our second question. I hope you understand this conservation of this compression of this spring math. This is something conceptual, that here I said that this kinetic energy is converted into potential energy. Okay, so this is the concept we have to remember to solve this kind of conceptual question. I hope you like this video. Please do subscribe to our channel and turn on the notification bell. Thank you.